Okay, so here it is, the last in the logic set of lessons, and we're going to look today at arguments. Now, this is a bit more complicated, and there's 4 different types of arguments that we need to look at and write truth tables for. One is implication, one is converse, inverse, and contrapositive arguments. Now, it's really, really important that you have down the truth tables for these and that you understand what they mean. So as we go through, make sure that you're pausing, drawing the truth tables, and check with me if you're not sure. Okay, I've just put up in red here the 5 connectives that are important to us. And we've got 2 example statements. You'll be pleased to know we're going back to 2 again. So we've got P, the TOK lecture is too long, and Q, Maya gets a headache. So I just want you to try writing the meaning of these statements here using those 2 sentences. So pause for a second and see if you can manage that. Okay, so for A, you should have the TOK lecture is not too long, and, because we've got a conjunction here, Maya does not get a headache. For B, the TOK lecture is too long, or Maya does not get a headache, but not both. Because look, we've got that little underline there. Now don't forget this should actually be touching the underline. Okay, so be careful when you write it out. For some reason on my computer, I can't get them to touch. But it should look more like this, the exclusive disjunction. Now C is one that we haven't looked at, and this is going to be our focus for the first part of today. It's the implication. So it's using if and then. So if the TOK lecture is too long, then Maya gets a headache. So that's what C should be. So let's have a look a little bit more in depth at implication. So implication takes the structure of if something, then something. And you should be using this symbol to represent it. Be careful because it looks really similar to the equality symbol, which has the arrow on the other side as well. So just be careful with that, okay? So we'll use the same sentences again. P, the TOK lecture is too long, and Q, Maya gets a headache. And we say that implication is true if the first statement leads to the second statement. So it's really important that you have your columns in the correct order. So in this case, we're going from P to Q. So I've got P first and then Q. But if it was Q to P, I'd want to switch them over. So, fairly obvious. If the TOK lecture is too long, then Maya gets a headache. If both of those things are true, both of those things happen, then this statement must be true. The next option is that the TOK lecture is too long, but Maya doesn't get a headache. So that means that the implication statement must be false because the TOK lecture has been too long, but it hasn't affected Maya. So this ends up being false. Now the next 2 possibly aren't quite so obvious because we can only say that an implication is necessarily false if the first statement is true but the consequence doesn't happen. The second statement doesn't happen. So actually in the case of the last 2 here, we don't know whether a TOK lecture being too long would give Maya a headache because the TOK lecture hasn't been too long. In this one here, Maya has got a headache. It hasn't been caused by the TOK lecture being too long, but it could be that if the TOK lecture was too long, Maya would still get a headache. So the implication would be true. Equally here, neither of the things can have happened, but we still can't say that it is definitely false. We can't say that if the TOK lecture was too long, that Maya wouldn't get a headache. because neither of those things has happened, so there's no evidence against it. Here, there's evidence against it. The TOK lecture has been too long, but Maya hasn't got the headache. So that means that this is the only one that can be necessarily false. Everything else we claim is true. It might seem a bit weird, but you've just got to get used to that, I'm afraid. So that's implication. Now, we can take implication, and don't forget as well, pause the video, draw down the truth table with the title implication, and give yourself a little explanation of what's going on before you move on to this next bit. Because we can take implication and we can turn it into a converse argument. So implication, we were dealing with P. If P, then Q. So the converse is if Q, then P. So let's have a look at what that means. Now you might think that this is just going to be the negation of if P, then Q, because it's the opposite. But it's actually not. So in this case here, remember we said the order matters. So Q should come before P. So if Maya gets a headache, then the TOK lecture was too long. Both of them are true, so the converse argument must be true. If Maya does not get a headache, but the TOK lecture was too long, then the converse argument that if Maya gets a headache, then the TOK lecture was too long could possibly be true. We don't know. Maya didn't get a headache, but she could do if the TOK lecture was too long. We're not sure. So this ends up being true. So remember, if the first thing is false but the second thing is true, we have no evidence to suggest that they're not linked. So we have to make it true. If the first statement is true but the consequence doesn't happen, so here Maya has got a headache but the TOK lecture wasn't too long, then we can't say that these two are linked. So this becomes false. And if both of them are false, then we have no evidence to suggest that they're not linked, so we have to still make it true. So just be really, really careful with the order. And look, it's not a negation. Here they are both true. Here they are both true. It's just the middle ones that change. The combination. So just be really careful. It's not as simple as negating. Now, just keep in mind this order here. True, true, false, true. Because our next set of arguments, and again, don't forget to write down your converse arguments and your truth table and a little explanation for what's going on. You may, in your converse argument, want to switch around the P and Q columns to make it a bit clearer for yourself. Because we're going to move on now to inverse arguments. And this does involve negation. So if we started off with if P, then Q, the inverse of it is if not P, then not Q. So we start off with P and Q, and then we negate them. So again, it is not as simple as negating if P, then Q. In that case, we'd have a negation, brackets, P, then Q, and that would be the negation of if P, then Q. In this case, we have to negate P and Q first and then see where we go from there. So if both not P and not Q are false, we have no evidence to suggest that these two are not linked, and so we have to say that this could be true. If not P is false, but not Q is true, we still have to say it's true. But if not P is true and not Q is false, then we can claim it as false, because the initial argument has happened, but the consequence has not. and so there's no way they can be linked. And if both of them are true, then obviously it comes out as true. And notice that this, for the inverse argument, is the same as for the converse argument. They actually come out with the same truth values. So make sure you get that down as well. That's the inverse argument. And then our final one is the contrapositive. So, if the original argument was if P, then Q, the contrapositive is if not Q, then not P. So we are negating and we're flipping it round as well. So in that case, I mean, I've done my P's and Q's the same way around here, but it would actually make more sense to flip them round and have QP, not Q, not P. And then exactly the same, if they're both false, then this has to be true. If the first thing is true but the second thing is false, then it's false. If the first thing is false but the second thing is true, it could still be true. And if they're both true, then it is true. And again, notice that this is the same as the original true, false, true, true. So implication and contrapositive arguments give the same truth values. Okay, now one thing that you might be asked to do in exams is called testing for validity. So you might be asked to test a statement for its validity. Now an argument is only valid if all of the truth values at the end of the table are true. So when you get to that final part of an argument, if it is all true, you can say it's a valid argument. If there's even one false, we call it an invalid argument. Remember as well that anything that is all true at the end is called a tautology. So a tautology is always a valid argument. A contradiction is when all of the truth values at the end are false. So a contradiction is always an invalid argument. But an invalid argument doesn't have to be a contradiction, because an invalid argument only needs one false in order for it to be invalid. And if we've only got one false and three trues, then it's not a full contradiction. So we need to have a bit of practice with using these words. And an exam question might say to you to analyse an argument. And what that basically means is to say, is it valid or invalid? Is it a tautology? Is it a contradiction? So have this screen up when you are answering some of these. I'd like you to just pick 2 or 3 questions from each exercise at the moment and mix it up. Don't just do the first 3. Okay, so mix it up and pick maybe the first one, middle one, last one. And try and work through as many of these as you possibly can, because it's going to give you some really good practice with answering arguments, because they're tricky. Okay, flick back to the last page, the last slide. Have that open in front of you to help you answer these questions.